Hello, this is Brett from Survival Comms, and today we're going to talk about this particular radio here. This is a Gladding Islander DF radio. This radio is probably from the 1970s, and these were a very popular item for small pleasure vessels, sailboats, things of that nature. And they were very popular because they were a source of entertainment. So outside of being an entertainment source, they also served a purpose as a redundant navigational tool using the direction finding features of the loop antenna. This particular radio picks up the long wave spectrum, which is 150 kilohertz to 400 kilohertz. And there are still beacons that you can pick up on there. Most of those beacons are related to aeronautical purposes. You can also use the AM broadcast band for direction finding purposes with the loop stick antenna that's built into the set, and we're going to demonstrate that in a few minutes. The radio also has the FM broadcast band. It does cover a certain portion of the shortwave spectrum, specifically on here 1.6 megahertz through 4 megahertz, and it also covers your long wave beacons, of course. And it covers your VHF aircraft spectrum.
127.47, 5 Charlie Echo, good day.
Be looking at Delta 361.
And it covers up the VHF marine spectrum, which also covers the 2-meter amateur band, covers the weather channels, and other forms of FM signaling within that portion of the RF spectrum.
FedEx 01, second transport unit request is en route. Vehicle accident, camera 450A and South Central Avenue, Umatilla, PS3.
This switch, when it's turned into the radio position, brings the telescopic whip antenna into the circuit, and that allows you to receive the FM broadcast band, the VHF air band, and the VHF marine band, which are all geared towards being vertically polarized. Now, if you look over here, you can see this is your tuning knob here, and this DF level is basically an RF attenuator, and it is only engaged with the loop stick antenna. So when you have the loop stick antenna in the circuit, this right here acts as an attenuator. This is your volume and on-off control. This is your band selector here. This control here is a tone control for your listening pleasure, and this AFC control right here prevents drift. On top there is a 1/8 inch earphone jack. This radio offers 2 sources of power. It uses 4 C-cell batteries, or it has a built-in transformer and can run off of household current. So on top here we have our bezel, which has our bearings on it, and you would essentially take and line this up with a compass. You would take your compass and establish your magnetic bearing, and this arrow indicates maximum signal, which is at 90 degrees in relation to the axis of the antenna itself. And then when you turn the antenna such as this right here, this minimizes signal and establishes a null. And when you're using this for direction finding purposes, you actually want to use a null rather than maximum signal strength. Check your heading with your compass. Now adjust your bezel ring to match. Find yourself an AM station, and if the signal's too strong, you can utilize this attenuator here, and you can watch on the meter here. You want to bring the signal strength up as close as you can where that DF level line is. Now with broadcast band, you're going to need to listen to some of the advertising or to the station identification where they give you whatever city they're in, so you can go ahead and mark that down on your chart or your map. Okay, we can see our signal here, and what you want to do is you want to adjust your loop here until you get a null. And you can kind of see Once you've established your null, then you're going to go ahead and that's going to establish a 180 degree axis. In our example here, we're 69 degrees and 249 degrees. Go ahead and do this with 2 more stations. You can see that most of your nautical charts also have your AM broadcast stations marked on their frequency and call sign. Most of your aeronautical beacons are going to be marked on your chart. Now, I found one in Melbourne is not marked on the current charts, but this particular one here is, and I've actually received this one here from my home in the past. So you can see that it's 332 kilohertz, and there's its CWID, which is FIS. Okay, well, we've seen how the charts have our AM broadcast stations on there. So let's say that we have an unknown location that we're at, and we have some coordinates already of these stations in question, and we can look on the chart and find those stations. So let's go ahead and run a back bearing back towards our location. So our first station is going to be at 285 degrees, and the back bearing will be 105. So what that means is that we'll do this right here to weight this thing down. We're going to go ahead and set our compass and orient our map and compass from magnetic north. And then we're going to go and set this for 105 degrees. So we take our bezel, rotate it to 105, and it's at 920 kilohertz. So what we'll do is we'll go ahead and line ourselves up for that, and we'll make a mark. You can see what you put the pencil in there, it affects the compass. Go ahead and make your mark. And then draw our first line. Our second line is going to be 275 with a back bearing of 95. Go from that particular station. Box our needle. Make our mark. And our next and final station is 305 degrees. So go ahead and take our bezel and mark it for a back bearing of 125. Box our needle. Make our mark. And then make our final mark, and now we have our location. We can use the same principles for land navigation as well. This is just a generic road map that you'd be able to get from a rest area or whatever have you. And we picked up some AM stations, and the advertising referenced these towns right here. So based upon triangulation, we're going to try to ascertain our position. So our first one was Gainesville at the 100 degree 280 line. So go ahead and orient our map north best we can, and then we're going to go ahead 100 degrees, rotate our bezel to 100 degrees, and that town was Gainesville, which is marked here. So from Gainesville, we'll go ahead and draw ourselves a line here. And our next one is Perry, 315. Set our bezel, 315. Box our line. And our next one is Live Oak, 25 degrees. Locks our line. And where the points intersect is our location. Now if you want to use this as a homing radio, go ahead and find your station. Go ahead and try to determine where the station's located at. And if you wanted to home in on that station, set your DF level. And you would just merely do the same thing as you did with determining which direction for finding your location. You would find your null, and then you would set your heading in a way that it would follow the bearing indicated on here. And as you deviated from that heading, what would happen is you would start to see your signals go up and down. And what you would do is you could correct your bearing based upon that. So it can operate as a rudimentary homing radio. I really love legacy stuff like this, and you know, if you ever get a chance to pick up one of these radios, I would encourage you to do so. You can get them pretty inexpensively, and they're kind of fun to play with. And I hope this helps. This is Brett from Survival Comps. Till next time.